So I'm going to let Jonas introduce himself. So over to you, Jonas.
Thank you, John. So my name is Jonas Gustafsson, working at RISE, which stands for Research Institutes of Sweden, at the unit called ICE Data Center, where we focus on everything you can find inside a data center, from the chip to the chiller, more or less. Also, everything, power distributions and so on. So thank you.
And if you ever get a chance to go and visit the RISE labs at Luleå, I would definitely recommend it. I was up there a couple of years ago in minus 37 degrees, which was a very interesting couple of days up there. Right, so first question, Jonas. Can we just define what edge and modular facilities are?
Well, edge seems to be a difficult one to define. It changes whoever you meet and you talk to. But I think we need to focus it around low latency services. On top, we have increasing focus on data sovereignty as well. Maybe if you look back 3-4 years when edge was coming, everything was around low latency, but the big amount of services required in this low latency seems to be growing a little bit slower than expected, and it's more focused on having the data close to you and don't let it diffuse into the unknown cloud where you don't have the trace of it. But then you can also think of the size of data center, of an edge data center, and the amount of power going into it. And also there, it's difficult to say. Some say that, an edge node could be a Raspberry Pi even. I don't know if I agree with that. But if you look at what some say networked edge, I would consider it from maybe half a rack or a single rack up to 10-20 racks of IT. And the power that requires, of course, might change now with this AI boom we're having, and more power going into each rack. So it's a very difficult question to define edge.
I know, and I think we've been having lots of debates at all the conferences that I've attended in the last couple of years. What is actually the edge? And I think, you can ask 50 consultants what the edge is and you'll get 50 different answers.
Exactly.
Which makes it a bit confusing. And for me, to me, it's the last point before you actually hit the user.
Yeah.
So that would bring into basically play small enterprise data centers, server rooms, mobile base stations, etc.
Exactly.
And I'm intrigued to find out what will happen with AI at the edge. But I know that you guys have been researching that. So what do you see as the cooling challenges at the edge?
Yeah, I mean, basically it's the same challenges in any data center. Maybe it's just because it's smaller and you will probably not have on-site staff all the time. That's one major difference to larger facilities. And that also brings complications where it comes to service and maintenance. You need to design to operate it out of bands for maybe years to come, and try to reduce or maximize the mean time between failures of the whole system, including the cooling systems. And one way of doing that is reduce the amount of moving parts you have inside the facility. So try to reduce compressors, look for really reliable stuff, and monitor it well. And I think there are things we can learn from other businesses when it comes to this predictive maintenance point of view, to also monitor and operate things, not only react on things when things break down, but make sure you operate it during under the best conditions, so to say.
Yeah. Do you think that then leads to a tendency to over-engineer remote sites for, so you've got a couple of cooling solutions that maybe cycle so that if one goes down, then you can the other one will be able to handle the duty until a remote engineer can go and visit and repair?
Yeah, I mean, it's a good question on how to address that, so you can sustain or keep the operational going, even at a little bit reduced performance for a while, but you don't have to shut things down. Yeah. And there it also comes into like the interoperability or the integration with the IT system. Okay, how hard can you reduce the maybe the quality of services this edge facility provides, given that the cooling capacity has been reduced?
Yes, it is a challenge, isn't it? At the edge of modular sites once we've defined them. Okay, so are there any solutions to address these challenges? I mean, I know that RISE is part of the EcoQ project. Is that correct? And you've been using AI at the edge to optimize airflow?
Yeah, that is true. RISE, we're part of the EcoQ project. Myself, not that much. I have a slight understanding, but we have run many other projects in relation to edge to see how you can, first of all, direct air if it's an air-cooled data center, using AI to kind of maximize the performance of each server, to try to switch off servers that are not used. And this is also related to maximize the temperature that you get out from one of these data centers, or any data centers in general, to optimize for both heat recovery and heat rejection, since it's easier to get rid of heat that's hotter temperature wise than if you have a mix. So going back to your question, if there are challenges or solutions to operate it, yes, it is. And I think it's back to this holistically control, where you also take control of the IT maybe, and operate that in together with the cooling system.
Yeah.
I think that will be seen more, and it's also maybe easier to do in an edge application than in a large facility or a co-location data center, where you have tons of difference of hardware. In a maybe a prefabricated edge data centers is easier to operate the IT in collaboration with the facility, and that could be an advantage, I think.
Yeah. And of course, if we consider the concept of software-defined data centers, it is possible with using edge in a kind of mist or fog configuration, that you can actually spread the load or have the ability to move the load in the event of a cooling failure at one site.
When you have this edge to cloud continuum, I mean, if it's not super critical latency-wise, maybe it can be moved into the next layer of the cloud architecture.
And then maybe sent down to the adjacent edge data center.
Yeah, that could be done as well. Yeah, for sure.
So monitoring, I think, is quite important as well, but then that also depends on where you are located. So edge sites tend to be at the boundary, quite a long way from certain urban environments in some cases. And that could be a problem for monitoring. So your site could go dark. And, what do you actually think about that then? So once it goes dark, do you send an engineer automatically to go and find out why it's gone dark?
Yeah, sooner or later you have to do it, I guess.
Absolutely.
But there could be different ways of acquiring the monitoring data, of course, using the traditional fiber connection that the data center is connected to, but you could also have backup system 4G and so on. But it's monitoring might be even more important in edge applications than in larger facilities, where you have, as I said before, on-site staff, and it needs to be considered that the how to make sure you get hold of the data, even if it goes black or loses its main power connection.
Our previous presenter outlined the Schneider Electric approach to cooling within data centers and with their plethora of products and solutions. And I was quite intrigued when he said about the transition stuff, moving from air cooled to liquid cooling. And of course, with liquid cooling, we kind of don't have a cooling problem, because if we're using immersed compute, our problem is to get rid of the heat. But at the moment, everybody wants to use that heat because it's of a higher value than what you would get from air cooled.
Yeah.
And I think that's quite interesting. So from an education perspective, do you see the need for the design companies and the design departments in IT, global companies and the transmission guys to be re-educated in the use of liquid cooling?
Yeah, I don't know if it's re-educated, but I mean, the focus is to maintain the temperature that you get at the CPUs and the heat-producing components inside the server, and try to maintain that temperature as long as possible throughout the heat reaction or the cooling chain.
So this is kind of outside the boundary of the data center itself, because we know that the EU are quite hot on waste heat reuse from data centers. And there are a number of projects around at the moment, such as Green Mountain with their lobster hatchery and their trout farm. And I know of projects in Scandinavia that are planning to use the heat into urban greenhouses for food production. And then obviously in the UK, we've got various projects at the moment centered around providing cloud type services for swimming pool and to offset some of the costs of swimming pools. And I think this is a massive opportunity for the IT community, as it were, globally, in the geographic locations where you can actually do this sort of thing, to be more of a integrated with the local communities and providing heat, especially with the energy crisis that's developed through the recent conflicts we've got. And I actually do genuinely believe that some of these guys really need to wake up and smell the coffee and start to look at, and start to address the global challenges of climate change and net zero when they're doing the design. And it seems to me at the moment that it seems to be growth at any cost. And I think they probably do need some education on that. That's just me. Would you agree with that?
Yeah, I think I would agree. I mean, recover the heat is something you should try in all cases, I assume. But sometimes it's not possible, unfortunately.
And I'm going to present you on this next, but the EU Code of Conduct for Data Centers Energy Efficiency is a series of best practices that apply to data centers in terms of reducing your energy consumption and being more efficient and sustainable. And I was looking at it yesterday, and there's 53 cooling best practices that apply, and it covers everything. And I'm going to cover that in a moment. But do you think that more organizations should actually participate formally in the code of conduct? And do you think that, well, we'll talk about that in a moment, but so what's your impression of the code of conduct? Do you think cooling is...
Yeah, I've skimmed through it a few times and tried to get understanding, and I think it's very well written, and I can't really criticize it in any way. The practices are all good, but I guess the challenges is for the data center operators and the designers and everyone to actually read it and understand it and consider everything that's in there, because it's a lot of stuff in it. And I agree with you. More should be involved in the development of it, and I think it can, of course, be maybe tailored towards different kind of data centers, what to consider and so on.
That's an interesting point, and I'll take that to the committee. There will probably be more about doing some best practices for specific types. So at the moment, in Europe, we have a number of legislation pieces that have recently been published and are now in force. And without going into a lot of detail, because I'll cover it in the next bit, part of that is to make more use of the waste heat. And of course, we've got the German Energy Efficiency Act, which kind of compels the use of waste heat. And I know that speaking to some German colleagues last week at an event, they are quite worried about how they're going to actually deal with that legislation.
Mm.
Um, so, how do you think? Do you think the legislation is likely to be part of that kind of design revolution to move to more energy efficient and sustainable data centers by using the waste heat?
Well, legislation is not really my topic, but
Yeah,
I think you need some kind of push from government and through legislations to actually make data center operators aware and start thinking of how to recover the heat. I mean, in Sweden, it's done. The bigger data centers that recover the heat, they do it through heat pump solution and inject it to the district heating uh, networks. That works sometimes, but you also need to consider what kind of heat sources you're, call it, competing against. I mean, data center is quite low temperature heat. You need quite substantial amount of extra energy, electricity, to reach the temperature level that it's possible to
yeah,
get rid of the heat in a or get rid of or sell the data center in a district heating environment. But I think we heard some of the, I don't remember where it was, but one of the previous speakers were saying, yeah, but, or he got a question that we don't have district heating outside Scandinavia, and that's partly true. But I know that there are being district heating systems being built in both UK and Germany and Austria and around Europe, and I think it's a big advantage with most of these systems because they are designed to accept heat at a lower temperature. Because
yeah.
they call it the old data district heating system we have in Sweden. They are designed for 75 degrees and above. You will not reach there even with the best liquid cooled solution I have seen. You will need a heat pump. But in the fourth generation or fifth generation that are being built now in many countries, which are designed for around 45 degrees or 50 degrees C, with a really good liquid cool solution, you can maybe even reach there without a heat pump, and then you're in a very good situation. So
Yeah. So you're referring to kind of underfloor heating in residential kind of blocks?
you could use that kind of temperature for underfloor heating, also for bigger uh, radiator systems and so on. It depends, of course, how you design the building at the other end of the heating chain. But
well, that goes back to my point about the education piece. So,
yeah.
the data center industry is, is actively looking into the reuse of its waste heat because it's being
Mm.
compelled to by legislation. But sometimes government policymakers and local authorities and people that are developing kind of master plans for areas are not, they're not aware of this solution.
No, they don't see the whole
Yeah,
concept.
absolutely. Yeah, I mean,
You can just force someone to, you need to recover the heat, but what's the use if it's
yeah,
some cases I've seen like that. Yes.
yeah, and I'm questioning whether or not it's the role of the industry itself to basically promote itself a little bit more to local authorities and the rest of the world's
Mm.
commercial activities, or
Yeah.
whether or not they should be approaching us and saying, look, we understand you're a heat source, and can we grab it? It's quite interesting. I'm looking at a project that's quite close to me at the moment, and I looked through the feasibility study document, and there wasn't a mention of digital heat in any way, shape, or form. It was all the conventional air source heat pumps, CHP plants, and that sort of stuff. So I have actually reached out to them and said, "Oh, can we have a presentation on digital heat? Because I think it might be quite interesting."
Yeah, because there's a good example there for instance, where you use ground source heat pumps or other heat pump installations where the source of heat is probably colder than a data center anyway, and in those cases, it's a no-brainer to use the waste heat source from from a data center instead of, I don't know, source water or whatever you might have as a heating source.
But it's part of a wider kind of, it has to be thought about when you're developing or retrofitting or redeveloping an area that you're going to actually provide the system for it. And you know, there's a big project near me at the moment. So I live quite close to the HS2 railway line. I say close to, it's about 10 miles away. And there is a big project just south of Birmingham. And we had discussions with them last year, and I looked at the master plan, and there wasn't even a data center allocated in this master plan. And very surprising, seeing as there was two universities that are taking space there. And then I approached them and I said, "Have you got a district heating system?" And they said no. And I was like, "Well, you know, why? Why haven't you?" And they just couldn't answer. And I actually personally believe that, you know, anybody that's doing a big development needs to consider A, the IT, and B, how you make use of that waste heat. And I'm just wondering, you know, is that something that we should be approaching some of the architectural firms? You know, because invariably I've done a lot of things in my life, but I've seen brand new buildings with data set or server rooms located in the center of the building with no access to the outside for free cooling. And on the plan, it says server room designed by others.
Okay. Yeah. It's good that you get involved in an earlier stage.
Well, yeah, we're trying to get involved in an early stage, but you know, sometimes it's quite difficult to find out these projects, because usually when you find out about them, they've already gone through the REBA stage 1 and stage 2, and then you're moving to stage 3 where you've got the more detailed design. But the thing is, the project's been signed off for planning and financing at stage 2. And you know, the concept's already in there. And if district heat or digital heat isn't included, then you don't hear anything. You know, you can't change the design. So I think we do need to speak to the architects.
Yes, we do.
Okay, and go on.
Now, yes, another aspect of that is also the dependencies you create between data centers and heat receivers, and how business models and risks should be divided. I think that could be one of the pain points to get a good solution into place.
It is.
Who should own what and so on.
Yeah. So I worked on the Catalyst project, which was an EU-funded project run by Grid IT Amsterdam and the SDIA, actually. And we did a lot of research into this, and that brings into the concept of the kind of how do you market heat as a data center operator onto it. But we focused primarily on district heating networks and the reselling of data center heat into the market. And as you quite rightly say, usually you have to stick a heat pump in to bring it up to an acceptable temperature for the district heating operator to actually integrate it into their thing. And that can affect the PUE metric, because you now have to include the electricity for the heat pump into your total facility energy. And you know, in a Nordic environment, you'd expect to have a fairly good PUE for a new build, you know, 1.3, 1.2 even. Well, as soon as you put the heat pump in, bang, you're up to 1.4, 1.5. And that can be problematic if you're trying to promote yourself as being as a low PUE source. So the other thing is, I was going to say, what solutions are available to address the legislative aspects? And I think we've probably already covered them. We've got the code of conduct, we've got heat pumps, we've talked about urban master planning, education. And I think the most important one is actually collaboration with different entities. And traditionally, the data centers approach has been rather island mentality. You know, we're designed to be off grid. We're designed to be kind of separate. We're very secure. We have lots of security protocols and aspects. And I think this might be part of the wider kind of data center image problem that we seem to have at the moment.
Maybe.
You know, it's with energy guzzling, cold eating, fire breathing dragons. And I think some more collaboration is probably in order. So can you tell us a little bit more about what research projects are underway at RISE at the moment in terms of cooling?
In terms of cooling, well, we're just about to start up a new project where we will look into liquid cooling and trying to reduce the thermal resistance in the heat reaction chain, as I was talking to all the way from the CPU, looking into different thermal interface materials that connect to the heat blocks in a district in a direct to chip system, for instance, and how to maintain the temperature as a highest possible temperature throughout the heat reaction chain. Because even if you're gonna react the heat in a dry cooler, if you plan to recover it in some sense, keeping the temperature as high as possible is, I mean, one of the general challenges here. Even if you're going to use it in a greenhouse or a district heating system, it doesn't matter. You want to keep the temperature as high as possible. Other heat recovery project that we're just about to close, one project called We District, where we have operated, you might have seen it, where we operated immersion cooling systems together with fuel cells, where the fuel cells produced power to power the servers in the liquid cooling system, and then we kind of chained the cooling systems from the district. The intention was to reject the heat directly into the district heating system by daisy chaining the immersion system with the fuel cells, because the fuel cells operate at an even higher temperature than the immersion system.
And
so
how
you
did
could
that, yeah.
Sorry.
How did it go?
It went quite well. We couldn't really match the temperature of the district heating system here, as in the winters it can reach up to 90 degrees. But I would consider that mostly an engineering problems in the fuel cells, because they are not optimized to recover the heat at those kind of temperature. They want to get rid of the heat at a lower temperature. But it at least shows the potential of thinking a bit wider than only buying electricity. I mean, if you have piped gas and you can produce power with the efficiency of maybe 55 or 60% on site, and also recover the heat, you have a really good combined heat and power plant where you also integrate the data center in the loop.
Yeah.
So that system is now being expanded in another ongoing project called E2P2.
Yeah.
So we'll see.
Really good. I've always felt that the data center industry needs to look at fuel cells in a slightly different fashion. So at the moment, kind of everybody thinks that they're a backup solution, and I'm actually thinking that maybe they should be a primary solution.
Yeah, in this case, it was.
Yeah. So if you have an array of cells, then you've got the inbuilt resilience already in the cells, because not all the cells are going to fail at the same time. You might get one of the cells fail, but and you can just extract it and put a new one in.
Yeah.
And I think that's something that we should be exploring a little bit more, and especially if we can use renewable energy and hydrogen from renewable energy to crack the water into to bring the fuel cell up. It doesn't have to be a fossil fuel based solution for.
No, of course not.
Yeah, I mean we are attempting to reduce the.
As you know already, that was one of the major challenges in the project we had, because we didn't have piped gas here, so we had on-site storage of renewable biogas instead.
And that's another thing, biogas, which is an integration with basically sewage systems, isn't it? So anaerobic digestion producing methane, and then methane to re-engineer the fuel cell. I mean, I said this last week on one of the panels, we have immense challenges in this industry. So firstly, we've got the AI problem and its projected energy growth, and that is butting up against the fact that we're closing fossil fuel powered stations and renewables isn't really reliable enough. And that's why we've got this headlong rush into developing SMRs, small modular reactors for data center sites and adjacent up. That's a whole nother conversation for a whole different panel, I think. But anyway, I think that's going to be quite interesting. But I genuinely believe that we have all the tools already in place to deal with the energy challenges for data centers moving forward. And it's just that some of the operators and the design companies need to start to think outside of the box, and that takes education. It's education of the design teams, but it's also education of the customers. I remember speaking to a Nordic operator about 8 years ago, and they happened to be located quite close to a massive substation that had the renewable energy from hydro of 140 hydro stations. There was 1.2 gigawatts plus of energy available 2 kilometers from the site, right? And we looked at the risk analysis. We basically said, well, what's the chances of this substation going down? It's been there for over 100 years and it's never gone down, right? And from a risk analysis point of view, you go, well, what's the impact of it? Well, quite high. But what's the likelihood of it going down? It was almost zero, right? So it had the lowest score. And quite rightly, the managing director of the firm said to me and to the rest of his design team, if that's the case, why have I just spent £4 million on backup generation? Right? We don't need it. And it's in a customer education piece. Customers expect there to be backup generation. But I think we're in a whole new paradigm now. And with software-defined data centers and all of the tools which we can steal from our friends in other industries, we have all the solutions available. It's just the industry and the senior people need to start thinking outside of the box.
I've seen similar things with engineering companies that, we're going to design and you need this amount of diesel generators to cover the worst case scenario. If you're going to run it on full power and you run out of steam and it's the hottest day of the year and everything, and if and they need to design for that because they kind of to have their back cleared, as we say in Sweden. I don't know if you can translate that into English, but to be on the safe side. But I think we need to start thinking a little bit more creative and take some chances and balance also the IT system. Maybe you can ramp down and switch off some of the non-critical stuff in those cases. Yeah. Also, when there might be now we're shifting away from heating, but if there is a lack of power in the grid, for instance, is FCR, different kind of frequency containment reserve actions and so on. We need to be a little bit more proactive also on the IT side, and not saying that we will always have the power available, the cooling will always be there. A hot day, maybe you can reduce some non-critical stuff just to avoid starting that last compressor.
Yeah, I mean, and what is truly mission critical in a data center? I mean, we've got this kind of concept that everything, all of the digital services that we consume are all mission critical. Well,
yeah, but I don't think so.
I agree with you. I think if an email goes down for the day, then fine. You know that it will be back up and running the day after. Go off and go for a game of golf, or or something, or enjoy the summer weather. So there is something there on risk. Anyway, we've got 3 questions, which I think we've only got 5 minutes left. So let's go through those. And let Kelly go through the questions.
I was going to say, I didn't know if you wanted me to jump in. I didn't want to break you off. Just quickly, thank you both again for tackling an unwieldy topic in such a session, and for handling it between the both of you. So thank you so much for that. So if I just quickly run through these 3 questions that we've had from the audience. Data centers are constantly receiving bad press, as you've touched on. Do you think that data centers are now leading the field in heat recovery and sustainability?
Yes. I don't know if you want to go first, John.
I think there's a lot of talk, and there are isolated cases where renewable energy and heat recovery are in place, and some of the big players. So for instance, I think it's one of the projects in Odense has got. They connect to the district heating system. We know that the Scandinavian data centers are almost compelled to link to their local district heating system. So these work. We've got the Green Mountain project, which is the hot lobster hatchery, which I once was described as frisky amphibians. And we've got the fish farm that Green Mountain are also working for. So I think it's there. It just needs to become a little bit more widespread.
Yes, I agree.
But again, we have to understand that it's location is important. right? And you wouldn't want to see a trout farm down in Madrid, for instance, or in the southern area, because it's likely to be, we've got to think about water conservation, which I think our colleague from Schneider was talking about, and the previous guy as well.
Yeah, but I can just add to that also the greenhouses. If you look at how much food we are importing in Europe, recovering the heat from data centers should be able to improve our own food production. Greenhouses primarily, and also other kind of foods, algae and fish and whatnot. But it needs to be scaled up. There are examples, islands, as you said, but I wouldn't say maybe claim that we are the leading one. We're one of them, and we should be able to do a lot more.
Yeah, there's a lot of process cooling that can be recovered from other industries and other sectors, such as cold chain and transport refrigeration and heavy engineering. Where they're using molten steel. I mean, if you can't recover heat from that, then you probably want to stop doing it. Okay.
Yeah, I'm just moving on. I'm just going to say I'm constantly intrigued by the data center lobsters, and I think they come up quite a lot, and I can't wait to have the opportunity to try one of those. So fuel cells will give up to 99.99% reliability. People get nervous if there aren't any generators attached.
Yeah, I mean, 4 nines is a pretty high reliability factor,
yeah.
And I can understand why people get nervous, but really, it's they need to address their own internal risk profile. So, and I kind of touched it in the last point. What is truly mission critical within the data center? Which actual services are the ones that are completely integral and essential to your business, and what can you do without? And the code of conduct, which we'll be covering in a moment, which, although it's not a cooling best practice, says, allocate priorities to your data center services, and perhaps maybe have different types of service within your facility. So class 4, EN 5600 class 4 uptime tier institute class 4 is really only necessary for, the highest mission critical applications. If you go down a little bit more, just be circumspect. And we've got the software-defined data center concept has been around for a long time now, and there are very few companies that actually use it. And I'm constantly amazed about that. But, we've had, I think, with the climate emergency and the net zero goals, necessity is the mother of invention. And if we can start to reevaluate what is truly mission critical, then we can start to think about it. But this one size fits all approach is not doing anybody any favors.
And Jonas, I don't know if you have anything to add.
No, well, 99.99%. Well, I don't think you only have one fuel cell. You will have a stack of them. So if one fails, there will be others. You will not rely completely on the fuel cells. You might probably also have a connection to the power grid that can take over if one of your fuel cells fails. So I don't see it as increasing the risk. I would rather look at it reducing the failure risk.
And to add to that point, I think the problem with fuel cells is at the moment they're relatively expensive. Obviously, the price will go down when we start producing them at scale, but we need to have the fuel source as well. So it's very much intrinsically linked with the hydrogen network that is embryonic, very embryonic, actually. I mean, there is, I think, certain European countries have a hydrogen strategy, but we using existing pipelines, and hydrogen is a tricky little particle actually to deal with.
It is.
Because it's quite small. So the actual engineering required, you can't have many leaks in the pipe network. You have to really think about how you do that. There is, I think that there is a term for hydrogen, but I see, we are blending hydrogen with other fuel sources at the moment and running over existing pipelines. So, but the thing is, the hydrogen kind of concept is going to take some years to pan out. And, this industry is historically very conservative. It comes back to our risk appetite, and we all, we'll try anything new as long as it's been around for 10 years.
Thank you. And just for our final question, before we move on to the next session, staying on the idea of fuel cells, we've not really considered hydrogen. We're constantly told by many in the media that co-locating renewables and battery energy storage is the future. We've heard very little regarding fuel cells other than as an alternative to batteries. Giving the little information, what do you think the key technological and infrastructural changes that need to be addressed if we were to decide to implement fuel cells as our primary energy system?
Well, I think we've just covered it. So the actual hydrogen needs to be completely kind of, we need to have something on that. Can you put the question back up, actually?
Oh, sorry. Yes. Just bear with me. Sorry, I've literally just. Do you want me to read it out again?
It's all right. I can click it on the answer. I just wanted to.
Okay. So would you like me to read it out again, or?
Oh, that's why I've got it now. So I was going to say, so yes, that battery energy storage solutions definitely have a place in an integrated grid network.
Mm-hmm.
If you look at Ireland, in some days they are producing far more energy than they actually use. But because they don't have any battery energy storage solutions or even pump storage solutions, it's literally being, I won't say wasted, because I think it comes over the interconnector and it's used in the UK.
Mm-hmm.
But, Ireland does have a bit of an energy system problem with the large amounts of data centers that have been installed and the unreliability. They've closed a few peat-fired power stations.
Mm-hmm.
So they should be investing in battery energy storage solutions. And I don't think it's just lithium and containers full of lithium batteries. There are other alternatives for long-term battery energy storage out there. And I saw one last year at an event I went to in the United States using sodium ion. Right. So, and that's again, it's embryonic, but and it does depend on raw materials that we can access.
I think that's a good thing to remember if you're going to build out massive battery storage, looking at the whole life cycle assessment of them, because they are not coming for free from a sustainability point of view. And then if you're going to use them just for a short amount of time, the kilowatt hours they produce will have a lot of carbon and other emissions entitled to them. So
back in the day, in the UK, we used to have an organisation called the Central Electricity Generating Board, and they were the guys that were responsible for planning the UK's energy infrastructure. And they actually developed 2 pumped storage solutions using baseline nuclear electricity to pump water from bottom reservoirs up to top reservoirs, and then using the top reservoir as a battery. So they used to kick in half time during the World Cup final. Everybody goes out and puts the kettles on, and bang, we need a bit of extra power. And they went from 0 to 400 megawatts in 20 seconds, right? Now these are big infrastructure projects, but we don't have a central electricity generating board anymore. So there's nobody that's doing this kind of long-term energy planning in the UK. And that's a result of, the dash for gas in the 90s, and to be perfectly honest with you, the abject just uselessness of the UK planning in terms of energy departments. I mean, this energy policy, we've privatised it, or maybe it should be brought back into centralised things so we can start to do this in the future. And, as I said last week on the panel, necessity leads to invention. Is the mother of invention. And, if the free market can't provide the energy that's needed for these new data centers and the growth, electric vehicles and heat pumps that we're planning to install across the UK as well, maybe some central planning has to take place. And that, and I'll hesitate, I wouldn't say this in an energy panel, but, maybe some of the utilities need to start stepping up their game. But coming back to the second part of that question, I think obviously we've got the Great Grid upgrade underway at the moment, right? And I think that's 19 projects that are to connect offshore wind, onshore wind, and other renewable energies into the national grid. A lot of people think that the energy system is stable. It's never been stable. It's always been in a process of evolution. So the existing 400 kilovolt high tension grid was only started in the 60s, right? So and that's only 50 years ago, and that infrastructure is being replaced. But I think if if the generating board, the CEGB, had been around, we would have already had our infrastructure in place, because we would have foreseen this and developed it. But because that department was closed down, we have had very little long-term energy policy and planning done in the UK for probably 40 years. And we're now reaping I won't say rewards, because it's certainly rewards, but we're reaping that situation.
The consequences of our inactions, perhaps. Yeah. And thanks for that. Jonas, have you got anything to add before we move on?
No, not really. Infrastructure change. I don't know if you're going to implement fuel cells running on hydrogen. That's it will take some time. But having fuel cells close to the data center as a primary power source to power your data center, I think that's a quite interesting aspect, because you can run it on traditional gas you have in your pipe gas network already now. It doesn't need to be pure hydrogen. And that thing, I think we will see more of as an alternative power source to the grid, to generate your own power.
But just on that point though, Kaylee, I go to a lot of events, right? And I speak to people.
Absolutely.
And I'm looking at LinkedIn stuff, and I'm hearing, data centers are going to be built here, and there's a data center going to be built there. And I look at them, and I make a point of going onto the planning portal, and I look at some of the documentation that's provided, and you look at the design, and I'm just thinking, man, I could be back in 1980 or 1990 looking at some of these designs, and I do not think that that can continue. We need to start. We need to have 21st century data center designs for the 21st century. We can't get away with 20th century designs for the 21st century, because they are, they're just not up for the job.
Inadequate. Yeah. Okay. I'm going to draw a line under that, but I just wanted to thank you again both so much.